All right, so today we're going to finish up lesson 1-3 and do part 2, absolute value inequalities. So your learning targets today, we're going to solve and graph absolute value inequalities. So what you need today is your Springboard book, something to write with, and a calculator to help you with some of our solving we're going to be doing. So we are on page 13 in your book, so we're picking up right where we left off after equations. And we're looking at what an absolute value inequality is. So the only difference between an equation and inequality is the little symbol that they use. We're not using equal signs anymore. We're using greater than or less than symbols, greater than or equal to symbols. So an absolute value inequality is an inequality involving an absolute value of a variable expression, meaning our x, our variable, is inside those absolute value bars. Now, before we actually do any solving, I just want to do a quick review of how to graph a solution of an inequality, because we're going to be needing to do that today. So I just have two inequalities here we're going to graph pretty quick. And I just want to remind us how we actually graph on a number line. So if you remember, we have the greater than symbols. And we have our less than symbols. Right? So if we have a strictly greater than or strictly less than, does anyone remember what kind of circle we would put on the number line? Well, it may have been a while, but we always put an open circle if it's a strictly greater than or strictly less than. And then based on the inequality symbol, we either shade to the left of that circle or to the right of that circle. So since this is greater than, the numbers that are greater than -5 are all of these numbers here to the right. So I would shade the number line, including all values to the right, because we're not saying that m equals -5. We're saying m is any number bigger than -5. So there's not just one answer. There's a whole range here. Okay. Similarly with number 2, anytime I have an equal to symbol, that implies we're using a closed circle on our number line to imply that, yes, we're also including that value. And then if we have a less than sign, x is less than or equal to 5, well, less than means smaller than, so it would be all the numbers shaded to the left here. Okay, so if you remember your few couple tricks for maybe Algebra 1, you can always use the inequality symbol as kind of like an arrow. It should point what direction it's going to be shaded to. Or you can always remember that the less than sign looks kind of like an L, just a little squished L. So less left. Okay, you can think of it that way. But now that we've kind of gone over that, let's actually do the examples from our book. So going through their example really quick, the steps are the exact same for equations. We're always going to start by isolating your absolute value. Okay, so if there's anything around the bars, we move it to the other side. And then we also split it into two inequalities, just like we did yesterday with the two equations. You split it into two inequalities. So it's the same idea where the first one generally looks identical to the original problem. We just drop those absolute value bars. So what's different on the second equation is the left side stays the same. We just flip the inequality and flip the sign of the number, okay? And then we have to worry about graphing our solutions. So once we have our answers, we use our open or closed circles, and then we're going to be shading the number line, okay? So before we get to more examples, I'm just going to talk about how we do the shading and why we shade the way we do. Okay, so if I have the absolute value of x is less than 5, that means that the values of x are less than 5 units away from 0. So let me show you what that means. So if I have a number line and I have 0, so remember -5 and +5, when we take the absolute value, could both equal 5. So they're both going to work here. So the values of x are less than 5 units away from 0. So if this is 0, that means all values have to be less than 5 units. So that means they're going to be here, or on the positive side, here. If I put my open circles on 5 and -5, it's all the values that are less than 5 units away from 0. So they kind of go towards each other. Versus a greater than, okay, if x, absolute value of x is greater than 5, that means the values of x are more than 5 units away from 0. So again, if I have my number line and I have 0, -5, and +5, what this is saying then is my values for x have to be more than 5 units away. So they would be shaded out, away from 0. Okay, so a little trick that I'm going to tell you guys when we're graphing these. If anytime you have a less than sign, you're going to shade your numbers by connecting them. Okay. And anytime we have a greater than sign, you're going to shade away from the numbers. Okay, so you're either going to connect your two numbers or you're going to shade away. So if I compare this to the problems that your book did for us, this one has a greater than symbol, and you can see that they're shading away from each other. Problem B has a less than symbol, so as you can see, they're shading by connecting those lines. So now let's actually do the problems. We'll do a couple together, and you're going to try some on your own also. So let's look at A. We have the absolute value of x minus 2 is greater than 3. So to start this problem off, I'm already noticing that there's nothing around the absolute value, so I don't have to isolate anything. It's already isolated. So I can jump to step 2 where I split it into two inequalities. So the first inequality stays basically the exact same, just dropping the absolute value bars. My second equation, I flip the sign, flip the number. Okay, so then if I go ahead and just solve each of these separately by adding 2, I'm going to get x is greater than 5. On my second equation, when I add 2, I have -3 plus 2. That's -1. So I have x is less than -1. So there's our two solutions. So if I put these on a number line, I'm not going to be too picky with your number lines, just as long as you have the two values you need. And you always put the smaller number on the left. And that's good enough for me. Okay. So we have just strictly less than and greater than symbols. So I'm going to use open circles here on my two values. And looking at the original equation, it's a greater than symbol. So according to my little rule I gave you, if it's greater than, you're always going to shade away. Now, if you forget that rule, you could just always graph these based on how the arrows are facing. If x is greater than 5, it's going to be shaded to the right. X is less than, so it's shaded to the left, -1. Okay. Let's do another one. I'm just going to make this a little smaller really quick for myself. I have more room to work. Okay, let's look at B. We have the absolute value of x plus 2 minus 3 is less than or equal to 1, -1. So I'm going to start by adding that 3 over so I can isolate my absolute value. So I'm going to have less than or equal to +2 there, -1 plus 3. Okay. Now that we're isolated, we can go ahead and split this into our two inequalities. So the first one stays the same. My second inequality, we flip the sign, flip the number. Okay, and then I'm just going to go ahead and subtract 2 to get my two solutions. So on 2 minus 2 is 0. -2 minus 2 is going to give me -4. So then to graph my solutions here, make sure you're always putting the smaller number on the left side of your number line. So -4 would go on the left, 0's on the right. I saw in my inequalities from my original problem, it's an equal to. So I'm going to go ahead and put closed circles here. And if I'm using my little rule that's on the right of my page here, if we started with a less than sign, That means we're going to connect our points. Either going to connect them or shade away. Okay. I'm going to go through C pretty quick since I've already done 2 with you. So we're going to start by subtracting 1 on each side. So 4 minus 1, that's going to give me greater than or equal to 3. So now that my absolute value is isolated, I can go ahead and split into 2 equations. First one staying basically the same. Flip the sign, flip the number on the second equation. So for these, we have a 2-step equation we have to do. So I'm going to start by adding 2 to both sides. So on the left, I get greater than or equal to 5. And then if I go ahead and divide both sides by 5, I get x is greater than or equal to 1. Okay. On my second equation, same 2 steps. Start by adding 2 to both sides. Negative 3 plus 2 is negative 1. And then when I divide both sides by 5, this one doesn't divide nice like the other one did. So we're just left with negative 1/5. So it's okay if you have a fraction. Okay, no big deal. Putting my numbers on the number line, negative 1/5 is smaller than 1. So I'm going to order it that way. I see closed circles again, so I'm going to go ahead and use closed circles on there because it's equal to. And then if I look back at the original problem, I see that it was a greater than problem. So when it's greater than, we shade away from each other. So less than, we connect, greater, away. Okay. So I'm going to have you guys try D all on your own. Okay. Maybe that's too small to see. Okay, so you're going to try D. The absolute value of 2x plus 7 minus 4 is less than or equal to 1. So give that a try, and we'll go over the answer here in a minute. Okay, if you got it right, you should have got that x is less than negative 1 and x is greater than negative 6. So if I graph that on a number line, negative 6 is smaller, so it goes to the left. Open circles. And since we started with a less than problem, I would shade by connecting the points. Okay, so that is absolute value inequalities. So just make sure you're following your steps, isolating your absolute value always first, splitting it into your 2 equations. Always have to have 2 equations, and getting 2 answers at the end. So the only extra step with inequalities that we didn't have to do with equations is graphing it on a number line. Because remember, inequalities don't just give us one answer, it gives us a whole shaded area with a bunch of answers that could technically work. Okay? All right, see you for the next video.